record. Okay, and then I'm gonna share my screen. So here's the board. Okay. The chat. I need to see the chat. So here. Oh, okay, Taylor. Thank you. Okay, thank you for letting me. Okay, thank you. Taylor. Okay, thank you. I got your name. Thank you, Taylor. All right. So, okay. Okay, here we are. Okay, perfect. So we can start, I guess. Well, so I was saying, so this is still the same section, section 2.1, and it's about tangent lines. So we did, I mean, yesterday I did a lot of examples of tangent lines. So it's tangent lines and derivatives. All right, so yeah, yeah, I introduced the notion of the derivative yesterday. So I said, so if you start with the function f, so you have a function f. So f of x be a function, and a number. Okay. So then if the number m equals to, so if m equals to the limit h going to 0, the limit of f of a plus h minus f of a over h. So if this number, so remember this number was, this m was the slope of the tangent line. So, and so yesterday I said, actually, if this number exists, if m exists, okay, because this limit here, this m is a limit, right? And we know sometimes the limit do not exist, right? Sometimes it exists, sometimes it do not exist. So what I'm saying is, if this number m, if this limit exists, then it's called the derivative. Oops. Sorry. So then it's called, so what's going on with the board? Okay. So then it's called the derivative. Okay, I think there's an issue with the board. What's going on? Okay. So I hope you see the board, guys. Do you see it?
Yes.
Yes. Okay. Okay.
Yes, we see it.
I have some problem connecting my iPad to the computer. I don't know what's the problem, but anyway. So then it's called the derivative of f of x at a. Okay, and actually, so if m exists, we say that, so it's called the derivative of f of x at a. It's the derivative of f of x at a, and if it exists, we say that f is differentiable at a. So, and so if the number m exists, then we say so then we say that f is differentiable, that f of x is differentiable at a. Differentiable at a. And so here's a new word, differentiable. Okay. And we denote and actually we denote the derivative we denote the derivative, and we denote the derivative by f prime of, so f prime of a, so that would be equal to this, to m. So m would be the derivative of f at a. So this notation here, this is, so it's f prime of a. So here, this is, so here, this is prime f prime of a. Okay, or so that's the derivative of f at a. Derivative of f at a. Right. So so you see, guys, this number m, which is, so we said it's the slope of, the tangent line to the function f of x at a. This number m is actually the derivative of the function f at a. It's f prime of a, right? So, for example, so here's an example. So I think I did this example yesterday. So example one. You can take like, let's start with some very simple function. Okay, so let's just say f of x is equal to 2x minus 1. All right. So my function f is 2x minus 1, and let's say a is 1. All right. And so what I'm going to do, I want to find, let's say, so let's check if, so the question is f of x differentiable at a, or at a equals to 1. Okay, and so let's try to find f prime of 1, right? So so to answer this question, to see whether a function f is differentiable or not, all you have to do, guys, is to compute this number m, which is the limit, this limit here, limit h going to 0, etc. Right? All you have to do is compute that number m, and if the number m exists, then we say that f is differentiable. If the number m do not exist, then f is not differentiable. So this notion of differentiability, I mean, you can compare it like to a continuity, right? And actually, we'll see later, like the connection between continuity and differentiability, right? So we will see some examples where the function is continuous but not differentiable, all right? And some examples where the function is not continuous and not differentiable, etc. So we'll see actually the relation between the continuity and the differentiability. And of course, I will explain in a couple of minutes, the idea or the intuition behind this differentiability. Okay. So anyway, so let's just first see how this number m works. Okay. So so if you have to check if a function is differentiable at some number, all you have to do is, so we have to compute. So there's only one step. So the main step is just to compute. So it's to compute m, right? Which is, again, definition of m, limit h going to 0. So h always goes to 0. Okay, so in this definition, h doesn't change. It's always going to 0. All right, and as I said yesterday, you can think of h as the distance between the number a and x. So you want x to approach a, because again, this notion of the derivative, or this slope m, it's it's actually a local I mean, it's a local thing. You know, it's just about, we said this tangent line is the best linear approximation of the function f in a small neighborhood of A. So we are really interested in a small neighborhood of A. We don't really care about what happens, far away from A, okay? So this H is always going to 0. Okay, so here, this is, it never changed, always. H always going to 0. Going to 0, okay? Then we have, in the definition, we have f of A plus H minus f of A, of course, over H. Now, okay, so we know A, I mean, it's given in the problem. A is, A is supposed to be 1. And f of x is the 2x minus 1, right? So in this definition, I need first, I need this f of A plus H. I need f of A, all right? And then I can compute my limit, right? So first, I'm going to start with the f of A plus H. So, well, A is, in the problem, A is 1, right? So I have actually m, that's the limit, h going to 0 of f of 1 plus h minus f of 1 over h, right? Because my a is 1. Now, okay, now let's compute this f of 1 plus h. So we need f of 1 plus h. So f of x is, it's given in the problem, right? It's 2x minus 1. So what would be I need f of 1 plus h, right? So all you have to do, guys, here's your x. So your x, you have to replace your x by 1 plus h. So x becomes 1 plus h. So this x here becomes 1 plus h, right? So that's 2 times 1 plus h minus 1, right? And you think of the circle like parentheses. So this is actually, like, f of 1 plus h equal to 2 times parentheses 1 plus h minus 1, right? So then f of 1 plus h is just 2 times 1, that's 2, 2 times h, and then subtract 1, right? So that will be 2 minus 1, that will be 1, and then what? 1 plus 2h, right? So I got my first, you see, I got my first term here. I got my f of 1 plus h. It's this thing here, 1 plus 2h, all right? Now, the second thing I need to compute in this definition is the f of 1, right? It's not, it's not hard. I mean, I know f of x. I know f of x is, 2x minus 1, right? So then f of 1 would be just equal to 2 minus, sorry, 2 times 1 minus 1. That would be equal to 1, right? Okay, so I got my f of 1. I got my f of 1 plus h. Okay, so I'm ready to compute the m, right? The limit, right? So now we can compute. So now we can compute m. So m would be limit h going to 0. F of 1 plus h, we said it's this 1 plus 2h, right? That's my f of 1 plus h in the definition here, right? So that's 1 plus 2h. There's a minus. Here's a minus. You see this minus here? So here's a minus here. And then f of 1 minus f of 1, f of 1 here, right here, right? F of 1, we said it's equal to 1, so it's minus 1, and then over h. Over h, not 1. All right, so so we can cancel out 1 here, 1 minus 1, right? Cancel out. So it's just now, m would be limit h going to 0, 2h over h, h over h. So the h cancel out, right? This is this h here goes away, right? H in the top and h in the bottom. So then that will be equal to 2. So my limit, my m, is actually equal to 2. So m exists, it's a number which is equal to 2, right? So the conclusion is my number m, so it exists, I mean, it's equal to 2, right? So m is equal to 2 exists, right? So if the number m exists, then f of x, we say that f of x is differentiable. So again, differentiable means that the derivative exists. Okay, so f of x is differentiable at, so a equal to 1, right? My number a was 1, right? So x equal to 1, right? And the derivative f prime of 1, again, a is 1, right? This 1 here is my a. This is my a, right? This is my a here. So f prime of a, or f prime of 1, is equal to the number m, which is m, we said it's 2, right? So then f prime of 1 would be equal to 2, right? This number here, 2. Okay. So this function here, f of x, is differentiable. The derivative exists at x equal to 1, and actually the derivative at 1 is equal to 2. And again, guys, we said, I mean, one of the interpretation, you're gonna see more interpretations later, but this is supposed to be, this number m is supposed to be the slope of the tangent line, all right? So, and that's actually the derivative. So yeah, so f prime of 1 here is equal to 2. Okay, so before the next example, is there any question, guys? Please, I mean, don't be shy to ask. Feel free to interrupt me and ask questions. All right. So
No, not yet.
okay. So okay. So this is just a definition. Okay, you can take it as a definition. We will see later more interpretations of this derivative. I mean, in physics, it has interpretations. Uh, um, I mean, we're gonna see a couple of interpretations of this number m. And okay, so let's do another example, kind of a simple example where this number m do not exist. So this is an example where m exists, right? So then f is differentiable. So now let me do an example where m do not exist. Okay, so then you can see. So example number 2. And I think I did this example yesterday, but anyway, I think many people missed the lecture yesterday. So this is a very good example, actually. Like it's a standard example. Okay, so f of x is, let's say, absolute value of x. Okay, it looks very simple. And let's say my a is 0. Okay, now, oops. So there's I mean, this absolute value of x is not, I mean, if you want to get rid of the absolute value, then your function f is going to be described by two different equations, right? So the absolute value of a number, of course, if it's negative, if the number x is negative, then the absolute value of x would be the opposite, right? It would be minus x. So so what I'm saying is f of x, this is actually equal to, so if my x is negative, then the absolute value is supposed to be the opposite, right? So it's going to be minus x. So this is if x is negative. And if x is positive, absolute value of a positive number would be the same number, right? So it would be just x. So if x is positive. So you see the absolute value is described by two different equations, by minus x if x is negative, and by positive x if x is positive, right? So that's for the absolute value. Now, okay, so that's good. Now, so I'm gonna try to see that. So let's see if f of x is differentiable. So the question is f of x differentiable at x equal to 0. Okay, and we're gonna try to find, f prime of 0. Okay, so there's only one step. The only step is to find the number m. So we need to find, we need to compute m. So we need to find m, which is again limit h always going to 0. Then f of a plus h, right? Again, the definition, guys. Oh, well, let me write down the definition first. F of a plus h minus f of a over h. So this is the definition of m, right? So of course my a is 0. I mean, you see here, this is x equal to 0. So my a is 0. All right, my a is 0. So that's so then we have, so limit h going to 0, f of, so 0 plus h. So this a here is 0. This a here is 0. This is a 0. So f of 0 plus h, well, 0 plus h is h. So that's just f of h here, right? Minus f of 0. So what's f of 0? What's the absolute value of 0? I mean, f of 0 is just the absolute value of 0, right? It's just 0. So minus 0 here, right? Over h. So my m is just limit h going to 0, f of h, okay? So h going to 0, so this is f of h here over h, right? Now the question, guys, so what's f of h? What's this f of h? So what would be f of h? Well, f of x is absolute value of x, right? So f of h is supposed to be absolute value of h, right? So I mean, this is supposed to be, so this is equal to the limit h going to 0 of the absolute value of h over h, right? Now, of course, so now if you want to compute this limit, and if you replace h by 0, you're going to have, of course, 0 over 0, and that's indeterminate form, right? So what do we do in this case? So this absolute value of h, so how do we get rid of this absolute value? So is it plus h or minus h? Is h positive or negative?
Negative?
Nope.
Will we do minus h since this positive?
So the thing is, h, you see here, h is going to 0, right?
Oh, so it's positive.
No, not really. Actually, it's positive and negative. It could be positive and it could be also negative because, this is 0, h approaching 0. So h could approach 0 from the left, right? Or h could approach 0 from the right. And I mean, if h approaches 0 from the left, then it would be negative. And if it approaches 0 from the right, then it would be positive. So, so what I'm saying here is that actually we have to distinguish between two cases. There are two cases. So, which means there are two limits because, h could be positive or negative. So this absolute value of h, it depends. So we're going to have then two limits. So then we have, oops, what happened? Oops, okay. Okay. So I was saying this is, so they're going to have two limits. All right. Well, so it depends if h approaches 0 from the left or h approaches 0 from the right. So the first limit, or the first case, is when you approach, let's say, 0 from the left. So if 0 approaches 0 from the left, then this absolute value of h over h, then h would be negative, right? Because h is on the left of on the left side of 0, so it's negative. So absolute value of h would be minus h. So this is the limit h going to 0 minus of minus h over h. And of course, then that would be, h cancel out. So it's just equal to -1, because this is times 1, so it's going to be just -1. And the other case is when h approaches 0 from the right. Oops. H approaches 0 from the right. So this absolute value of h over h, so this limit would be h going to 0 plus. And so in this case, if it's our h approaches 0 from the right side, then h would be positive. So then absolute value of h would be positive h. This would be positive h over h. And of course, then h cancel out. So, and then it would be, because this is h times 1, so it's just, so it's going to be positive 1. So you see, so my number m, so you see here my number m, which is supposed to be this limit here, this one here. Well, actually, there are two cases, depending whether h approaches 0 from the left or the right. So, I mean, this and the definition of m, this is supposed to be a limit from both sides. So this is supposed to be both sides, right? And well, I got, from the left, I got -1. From the right, I got +1. So the limit from the left is not equal to the limit from the right. So then the limit from both sides do not exist. Does it make sense, right? So, so this limit from the left, is not equal to the limit from the right. So then the limit from both sides do not exist. Come on. So then the limit from the both sides, so then this m, which is equal to the limit h going to 0 of absolute value of 0 over, absolute value of h over h. So then this limit here from both sides, so this is from both sides. So this number m here do not exist. Okay, so then this number do not exist. Right? And so if this number m do not exist, it means that f is not differentiable at 0. So then f of x is not differentiable at 0. And f prime of 0, this derivative of f at 0 do not exist. This is supposed to be equal to m, right? F prime of 0, that's my m. So this number here do not exist. Right? So the thing, guys, is that you actually, this is this conclusion here. You can even see it from the graph of absolute value of x, because there's a geometric interpretation to this, to the fact that f is not differentiable at 0, because if you graph absolute value of x, let's say this is your number line here. All right, and so if you graph absolute value of x, you're going to have something which looks like, the graph would be like this. So this is the absolute value of x. right? So here you see at 0. So what happens at 0 is that you see the slope from the left. The slope here from the left is actually, because the function is going down, so then the slope is negative. So here the slope is from the left is -1. And now on the right of 0, the slope here is actually positive because the function is going up, is increasing, right? So the slope here is positive, +1. And that's actually this -1 here. That's that's our the limit when h goes to 0 minus. So this is our limit actually, h going to 0 minus, and the slope +1. That's our limit when h goes to 0 plus. So so the slope from the left is different, right? It's not equal to the slope from the right. One is -1, the other one is +1. So that's why f is not differentiable, all right? Because you see the slopes from the left and from the right, they are actually, they are different, all right? So that's why f is not differentiable. And actually this is a general fact. So if in the graph you have like a corner, if you have like a corner or a cusp, so so this is like a general fact actually. So general fact. So whenever you have a corner in a graph, so if you have like a, so what I mean by corner is like, you have like a vertex, like if it's like you're having like a triangle, right? And so you have like a vertex, all right? So this is your corner. Okay, so then this graph here, let's say this is f of x. Then this function f is not differentiable at this corner. Okay, so f of x is not differentiable at this corner. All right, so that's why when a function fails to be differentiable. Okay, remember, like we said for continuity, we said like if you have a jump or a hole or a break in the graph of the function f, then the function is not continuous at the jump or at the break or wherever. Now for differentiability, if you have a corner, all right, like here, absolute value of x, you have a corner at 0, then the function is not differentiable at that point because, again, derivative is about slopes, right? And what we are saying is that like the slope coming from the left is different from the slope coming from the right. So then f is not differentiable, right? Is there any question, guys? Does this make sense to you?
It makes sense.
Okay, perfect. So this is, well, let's have one more example, and then I'm gonna give you probably an exercise so we can practice this definition of M.
Professor,
Yes.
can you finish the one we started yesterday?
Yes, so that's what I'm gonna do, yes.
Okay.
Yes. So that's the example number, oops. I don't know what's going on with the board, but I have to fix this problem, I guess, at some point. Anyway, so that would be example number 3, yes. So so what was the example number 3? Well, I think it was, I mean, please correct me if I'm mistaken. So f of x is, let's say, I think it's x squared minus 2 and 2x minus 3, right? If I'm not mistaken. So if x less than 1, and here if x is larger or equal to 1, right?
Yes.
Okay, perfect. So So the question is, let's say you want to check if f is differentiable. So is f of x differentiable at x equal to 1, right? And so we need to find f prime of 1, right? So let me ask you this, guys, before the differentiability. So remark, is f of x continuous at 1? Is it continuous at 1? At x equal to 1. Well, before this example, if I come back to this absolute value of x, is absolute value of x continuous at 0? So in this example here, in this one here, this is absolute value of x. Is it continuous at 0? Do you think it's continuous at 0? Well, we proved that it's not differentiable.
No. Yeah.
It's
Yeah.
continuous?
Yes.
Yes, it's continuous because I mean, there's no hole or a jump at 0. I mean, you have a continuous curve, right? You don't interrupt your, or you don't stop your curve at 0, right? There's no jump or a break at 0, so it's just a continuous graph, right? So this is obviously continuous at 0. So this is a really good example because you see it's continuous, but still it's not differentiable, right? It's continuous at 0, but it's not differentiable. So let's come back here to this example number 3. So my question is f of x continuous at x equal to 1? Remember, guys, to check the continuity, you have to, you have to first compute f of 1. You need to check, oops, so you need to check f of 1. You need to check, the limit of f of x going to 1. So, so what will be f of 1 here? F of 1 is equal to, so which equation we're going to use for f of 1?
The second one.
The second one, right? Because we have here, it can be equal, right? So f of 1 would be just 2 times 1 minus d, which is -1. Now, if you want to compute the limit of f of x going to 1, well, here, x approach 1, of course, x can be less or larger than 1, right? If x approaches 1 from the left, then it would be less than 1. And if it approaches 1 from the right, so it's going to be larger than 1, right? So here, we're going to have like 2 cases, right? So there's a case when x is, so the case when x is less than 1. So here x is less than 1, and here x is larger than 1, right? Because x less than 1, it means that x approaches 1 from the left. So that would be like the limit f of x approaching 1 from the left, and here x larger than 1. So actually x, that's when x is approaching 1 from the right, right? So if x approaches 1 from the left, so I mean, if x is less than 1, then of course, if x is less than 1, we're going to use the first equation, right? That's when x, as you can see here, that's when x is less than 1. So we're going to use the first equation here. So that's limit x going to 1 minus of x squared minus 2. And here, x is larger than 1 because x is approaching 1 from the right. So x larger than 1, then we're going to use x here is larger than 1. So we're going to use the second equation. So that's 2x minus 3. So here, you just replace x by 1. You get, if x is 1, then you get 1 squared minus 2. That will be -1. And in the second one here, the same thing. You get -1, right? 2 times 1 minus 3, it's -1. Okay, so either from the left or from the right, you're going to have -1. It's they are equal. So the limit from the left is equal to the limit from the right. So then the limit from both sides, this one here, so then this limit here exists, and it's going to be equal to -1. right? So then, so then my limit of f of x going to 1 exists, and it's equal to -1, which is the same as, remember guys, f of 1, we said it's -1, which is the same as f of 1, right? So then f is, f is continuous. F is continuous at x equal to 1, right? So then f of x is continuous at x equal to 1. Right? Okay, so that's good. Now let's check the differentiability, right? Let's see if f of x is differentiable at 1. Okay, so you need to see the difference, guys, how we check the continuity and how we check the differentiability, right? So it's like, it's two different, it's the two different notions. Both are about limits, but I mean, still they are different. So this is for the continuity. Now I want to check, let's check the differentiability, right? So now let's, now let's check if f of x is differentiable at 1, right? So all you have to do is to compute, the number m. If the number m exists, then you're good. Then the f is differentiable, etc. If the number m do not exist, then of course f is not differentiable. So let me remind you, m is supposed to be the limit, h going to 0, f of a plus h. So a here, guys, is supposed to be, so a is supposed to be 1, right here. So x is equal to 1. So my a is equal to 1. Okay, so a is 1. So that will be, so here, so here, is there a problem with the board, or do you
It keeps going in and out.
okay.
It's fine right now.
Okay. I think it's well, it's a new technical problem. Anyway, I will see what. I think probably it's the connection between the iPad and the computer. I don't know. Okay, so this is so I was saying this is f of a plus h. Come on. Okay, guys, I'm gonna stop sharing this screen, and I'm gonna share again. Let's see if that fixes the problem. I'm sorry about this interruption. Okay. Oh, come on. Okay, let's see what's the problem here. Okay, let me. Okay, let me. Okay, let me check the screen again. Okay, this is really weird. I'm sorry, guys. I think I have to. Okay, probably I have to unplug and then plug again the wire here. Let's see. Okay. Okay, I think now it's gonna work. Um,
What happened to the top of this bucket? Do you know what happened to the top?
Oh, it should have been there. It's
okay.
right there on the floor. Or open the garage, it's probably on the floor there.
Okay, let's stop sharing the screen. I don't know. It's beeping. I don't know why it's beeping, but let's see. Come on. Sorry, guys. I think there's something wrong with the wire. Let's see. Okay. So let's share the screen. Do you see the board?
No,
Yeah.
it's like loading.
It's
It
uploading.
says you're starting sharing it, but it's loading still.
Okay. That's. Oh wow. Okay. Okay. Let's stop sharing because I think it's not gonna work. I'm gonna change. I'm gonna use a different wire. So let's see. Okay. Hopefully this one's gonna work. Let's see. Okay. I think this one. I think this wire would be. Okay. Probably I should turn off and then turn on the iPad, I guess. Okay, come on. Okay, probably I should. Okay, probably, but I'm gonna lose my board, so I'm gonna just probably. I'm gonna download the notes first. I don't want to lose them. Download the notes. Okay.